So basically esters compound which are having C double bonded with O and O. So but oxygen can be on the right hand side of the carbon, oxygen can be on the left hand side of the carbon. So if oxygen is on the left hand side, if oxygen is on the left hand side of the carbon, so then left hand side will be the branch and right hand side will be the chain. But if oxygen is on the right hand side, so the branch will also be on the right hand side and the chain will be on the left hand side. So first we name the branch. The branch should always have YL and the chain should have O8. Branch should have always YL and the chain should have O8. So another structure, like if I say CH3, CH2, O, C double bonded with O and CH3. Which side we have a branch here in this structure? On the right hand side or the left hand side? Which side we have a branch? So branch is attached with the oxygen. So in this case, when you check the branch, this is C double bonded with O. So branch is on the left hand side. So the part which is attached with the oxygen is a branch, and if oxygen is on the left hand side, branch is on the left hand side. If oxygen is on the right hand side, the branch is on the right hand side. And this carbon is considered as a chain. So this one is a branch on the left hand side and this one is a chain. And the name of ester should always have O8. Now, there are two carbon atoms in the branch. So what prefix I should use for two carbon atoms? So it's eth because of two carbon. Then because it's a branch, so it should be YL, ethyl. In the chain also it contains two carbon atoms, so we'll say eth. Between the carbon atoms, there's a single bond between the two carbon. So it will be N. And because of the functional group, it is O8. So it is ethyl ethanoate. Is it clear? Ethyl ethanoate, the structure. Another example of this, ester, on the same page. So in this case, because I erased the branch from the left hand side, so the left hand side is a branch and the right hand side is a chain. What is the name of this ester? How many carbon atoms in the branch? So it contains 3 carbon atoms. So what will be the prefix used for 3 carbon atoms? Because for 3 it will be prop, and because it's a branch, so it will be YL. So it is propyl. And on the right hand side we have a chain which contain 4 carbon atoms. So there are 4 carbon atoms in the chain. So we'll say but, because of 4 carbon atom, between them there is a single bond. So we'll say N. And due to this group, we call that as OH. So it is propyl butanoate. Hydrocarbon which you will study, or a functional group basically, that is halogen alkane. Halogen alkane means alkane hydrogen is one of the hydrogen is replaced by, or one or two hydrogens or more than that, replaced by halogen such as fluorine, chlorine, bromine and iodine. If fluorine replace, then we'll use the term fluoro. If chlorine replace, we'll use the term chloro. If bromine is there, we'll use the term bromo. And if iodine is there, we'll use the term iodo. So fluorine, chlorine, bromine and iodine. The rule is the same way. We'll select the longest carbon chain. Numbering starts from nearest halogen, then prefix for carbon, and N for single bond, we'll use N, and then position of halogen and name of the halogen. Example, fluoro, chloro, bromo, iodo, and at the last prefix for carbon, and then for a single bond, we should end at ANE. So example, if I draw the structure CH3, CHBr, CH2, CH3. So what's the rule? Select the longest carbon chain. So we select the longest chain of the carbon. We have this as the longest carbon chain. Then numbering should start from a nearest halogen. So if I number from right hand side, so 1, 2, 3, 4. If I number from left hand side, 1, 2, 3, 4. So which numbering I should follow? Left to right or right to left? Which numbering I should follow here? So we should follow from left to right because the halogen is coming closer when we follow from left to right. So it's coming at 2, otherwise it's 3. Position of the halogen. Which position we have a halogen? Second. Which halogen is attached? Bromine is attached. So we'll use the term bromo. So it is 2 bromo. Means second position, bromine is attached. So we'll say it's 2 bromo. 4 carbon atoms. So for 4 carbon atoms, we'll use the prefix but. What is a bond between the carbon atoms? A single bond. So we will say ane. But whenever it's ending like, so it is butane. So 2 bromo butane. So name of this compound is 2-bromobutane, which means or shows that bromine is attached with the second carbon. Is it clear? But if 2 groups are attached, so if 2 identical atoms of halogen are attached, then we'll use the word di. If 3 identical atoms of halogen are attached, we will use the word tri. And if 4 are attached, 4 identical atoms of halogen, then we'll use the term tetra. So example, if 2 identical atoms, like example, if both bromine, like 2 bromine atoms are attached, if 3 bromine are attached, we'll use the term tri, 4 are there, we'll use the term tetra. So example, you have a halogen alkane, so CH3, CH2 and CH3. And it contains 2 bromine atoms, one at the top, one at the bottom. So what is the rule? The rule is select the longest carbon chain. So we select the longest carbon chain. That's from left to right. Which side I should number? From left to right or right to left? Which position I should number? So I should number from left to right. So 1, 2, 3, 4. So I have bromine attached to the second carbon. And how many bromines are attached? How many bromines? 2 bromine atoms are attached. So first this 2 is the position of the bromine. This 2, first 2 is for position of first bromine, and second 2 is the position of second bromine. So the number 2 is representing a position. 2, 2 means there are 2 bromines, both are attached with the second carbon. Because there are 2 bromines, so I will use the term di. I will say dibromo. And there are 4 carbon atoms, so I will say but. and they have a single bond, I will say N. So it is 2,2-dibromobutane. Why it's 2,2, not only single time, because one of the two is representing position of the one bromine and the second two is representing the position of the second bromine. That's why it is 2,2. Not only single time I use the term 2. So it's 2,2-dibromo and there are 4 carbon atoms. So we'll say butane. Is it clear? Another example, if 3 bromine are attached or 3 chlorines are attached, like example CH3, Cl, Cl, CH, CH2, CH3, and here is Cl. So in this case, we have 3 chlorines are attached, 3 identical atoms are there. What's the first thing? We'll select the longest carbon chain. So we select this as the longest carbon chain. Numbering should start from nearest branch. If I number from right hand side 1, 2, and 3. So branch is coming at the 3rd carbon or chlorine is at the 3rd carbon. If I count from left hand side, so 1, 2, 3, 4, 5. So second position, the first branch is at second position. So this is the closest one. So I will follow numbering from left to right hand side. So it is second position, I have one chlorine. Second position, I have another chlorine. And third position, I have another chlorine. So it is 2, 2, 3. And how many chlorines are attached? 3 chlorine. When 3 identical atoms, we'll use the term tri. Because it is a chlorine, so I will use the term chloro. So 2, 3, 2, 2, 3, trichloro. And there are 5 carbon atoms, so I will use the term pent. And they have a single bond, so I will say N. So it is 2, 2, 3, trichloro-pentane. Is it clear? Second position and third position, we have branches. That's why 2, 2, 3. 3 chlorines are there, so we use the term tri. And because there are 3 chlorines, so we use the term chloro. Pent, because there are 5 carbon. And ane, because they have a single bond throughout the chain. Why we cannot take from right to left the counting? Because if I count from right to left, this is 1, 2, and 3. So the first branch is coming at 3. But if I count from left to right, 1 and 2, the first branch is coming at 2. So we always follow the numbering where the branch is closer. That's why right to left is not a right way to count the carbon atoms. It should be from left to right in this example. So if I summarize what we just did for organic chemistry introduction, we started with alkane. Alkane can be straight chain, it can be branch, or it can be cyclic. How you identify the compound is alkane? So throughout the chain, there is a carbon-carbon single bond. It means that's alkane. Alkene, if between the carbon and the carbon, there's a double bond, we call alkene. For alkane, the name should have ane. For alkene, the name should have ene. Then for alcohols, this contain OH group and the name should have OL. Then carboxylic, these carboxylic groups, it contains C double bonded with O and OH. And the name should have oic acid. Then esters, the ester, it contains C double bonded with O. Either oxygen is on the left hand side or oxygen is on the right hand side. And their name should have O8. And the halogen alkanes, they contain fluorine, chlorine, bromine, or iodine. So with the carbon chain attach either a fluorine, either a chlorine attached to carbon chain, or bromine attached to carbon chain, or iodine attached to carbon chain. It can be on the left hand side or on the right hand side. So this is what we did for the introduction of organic chemistry, how to name these compounds. So I'll give example for each now, so that but I want you to name these compounds. The first example, CH3, CH2, CH2, and CH3. What is the name of this compound?
Alkane.
No, this is alkane. You don't have to send picture on the group, just mention now.
Oh, the name of the alkane.
Yeah, name of this compound. So it is butane.
Butane, yeah.
4 carbon atoms, they have a single bond throughout, that's why it is butane. If we have CH3, CH2, CH, and CH3, and there's a branch down. What is the name of this compound? What we call this? No, we select the longest carbon chain. This is a branched alkane. So branch alkane, we select the longest carbon chain and we count the carbon atoms from the nearest branch. So 1, 2, 3, 4. So
Yeah,
second
butane.
position we have a branch. So branch, it should always be, if a carbon branch is there, it's methyl. So it is 2 methyl. Second position we have 1 carbon, so it is meth.
Yeah, 2-methyl butane.
Because it's a branch, so it's YL methyl, and 4 carbon, so it is butane. So it's 2 methyl butane. What is the name of this compound?
Cyclo,
Yes, cyclopropane.
cyclopropane.
Because there is no N, so that's why we use the term cyclo. And prop, because there are 3 carbon atoms and they have a single bond, so it's N, cyclopropane. CH3, CH2, CH2, CH double bond, and CH2. What is the name of this compound? What is the name of this compound? 6 carbon atoms are there,
Hexene.
but the position of O double bond is also hexene,
Yeah,
means
Hex2ene.
so it is hex2ene because the double bond is not with the first carbon, so you have to mention the position. So it is hex2ene. Why hex? Because 1, 2, 3, 4, 5. So double bond with the second carbon. If I count from other side, double bond is far away. That's why it's hex2ene. CH3, CH2, CHOH, CH3. What is the name of this compound?
Butanol.
Not butanol, because again you have to select the carbon chain. It's
Yes.
then the position of OH is also important. So OH is attached with the second carbon. So 1, 2, 3, 4. So it's but because of 4 carbon. So but is because of 4 carbon, and N because of the single bond. Then the position of OH is with the second carbon, so it is 2 all. This is the 5th one only, not the 6th. This is the 5th one. What is the name of this compound? What's the name of this compound? This means carboxylic group. C double bonded with O and OH means carboxylic. Because there are 4 carbon atoms, that's why it is but, single bond ane, and due to carboxylic, it is acid, so it's butanoic acid. C double bonded with O and O, CH2, CH3, and CH3. This is an ester. What is the name of this compound? Yeah, that's right, Afif. Methyl propanoate. Why methyl? Because there are 3 on the left hand side, this is a branch. On the right hand side, this is a chain. So 1 carbon, that's why it's meth. But because it's a branch, so it is YL. 3 carbon, it will be prop, single bond ane, and due to functional group, it will be OH. So it is methyl propanoate. And the last example for this, CH3, CH, and CH3. What is the name of this compound? Yeah, what's the name of this compound? It's 2-bromopropane, that's correct. So second position, we have a bromine, that's why we call 2-bromo. And prop because of 3 carbon, and ane because they have a single bond. Is it clear? So you should be able to name these hydrocarbons according to the structure. If anyone want to see the previous example, you can take the screenshot. This is just the example which I gave. Already you drew these structures before. Just to recall the idea, I give this example again. They ask to name the molecules. They give you the structure and they say give the name of the molecule. That's why, or sometime you have to draw the structure from the name. But in this case, the common question is name the hydrocarbon or name the functional group or compound from the structures.
Sir, what is the functional group?
The molecules or elements which are attached to the carbon are known as the functional group. Like this, yeah, the OH group is attached, so functional group is OH here. This C double bonded with O and OH, so that's a functional group. Bromine is attached, it's called a functional group.
Okay.
So the molecules which are attached with the carbon instead of hydrogen are refers to functional group. The C double bonded with O, that's called a functional group.